this you need to know, although you're going to get your weather off your drone app probably. So there are weather briefings, and it includes the weather, notices to airmen, something that is significant in that area that the pilot has to pay attention to, and is either very short term or just didn't make the last sectional chart. And the last is TFRs, temporary flight restrictions. So the president may be coming to town. You may have a active fire scene. There's a number of there's a number to issue TFR. So how do you get this briefing? The FAA says you need to call 1-800-WX-BRIEF. Now you talk to a person, and in that the person is allowed to give you advice. Like, do you think I should avoid this area and fly around it rather than through it? So there's three types: standard, abbreviated, and outlook. Standard is the standard. It's the most complete weather briefing, and for the pilot who doesn't have an opportunity to gather any other weather data before. Adverse conditions, VFR, visual flight rules, flight not recommended, synopsis of the current weather conditions, TFR, and NOTAM. So that I want to fly, I do a standard weather briefing. Abbreviated. Well, let's say my flight was delayed by 2 hours. I can go in for an abbreviated weather briefing, and it's just to update the previous weather data they've gathered. This is for pilots who need to update previous weather data they have gathered and who only need bits of weather data to complete their weather picture. Outlook. This is if you are going to fly no sooner than 6 hours from now, and you just kind of want to get a sense of what the forecast information appropriate to flight route. This will allow the pilot to make an initial decision about feasibility. I've seen a lot of questions on stable versus unstable air. Stable air is typically stratiform clouds. Those are the swifty, high, just kind of no vertical feature to them. During stable air, the wind speed is low to no. And so your visibility may get bad because of stuff building up in the atmosphere and not blowing away. If it is raining, it rains a constant and continuous rate. Unstable air. Probably the best indication or most common indication of unstable air are cumulus clouds. You look for a vertically building cumulus cloud. The ground gets hot, it picks up moisture, it goes up in elevation. The higher you go, the cooler it gets. You reach the dew point, and eventually it will start raining. So those big old beastie clouds usually at the end of a warm day are cumulus clouds. Unstable air is cumulus clouds, good visibility because everything's blown away, and showery precipitations. Thunderstorm life cycle. You got three stages: the cumulus stage, the mature stage, and the dissipating stage. You really can't visually determine where it is in that kind of continuum. But if you look at this example, you see cumulus stage is when the clouds are building, getting higher and higher and higher in elevation. The mature stage is where all that moisture that's carried aloft can't be held by the air anymore, and it rains. It's an uplift wind on one side, and then there's downdrafts on the other side. So when it's raining is in the mature stage, and then the dissipating stage is where it's about run out of juice and is just dumping rain to get rid of it. A little bit of downdraft. I will give you a hint. Do not fly your drone in the rain. And inside the drone is an indicator strip that if your drone gets wet, it will tell the repair technician your drone got wet, and they have the right to refuse even warranty repairs. The biggest, greatest turbulence are clouds that are called cumulonimbus. So those are cumulus clouds. Nimbus means rain, and they have reached the mature stage or dissipating stage and are causing it rain.
Now let's discuss atmospheric stability. Atmospheric stability describes a state in which air resists vertical displacement. It's hard to move the air. It's just there, stagnant and still. Unstable air, on the other hand, is when it's very easy to displace the air in the atmosphere, so we get turbulent airflow. Stable air is characterized by smooth air, fair to poor visibility, stratus clouds and fog, and continuous precipitation. Unstable air, on the other hand, is characterized by rough air or turbulence, good visibility except in blowing obstructions, cumulus clouds, and showery precipitation. Weather conditions that affect performance include atmospheric pressure and stability, uneven surface heating, which causes air to rise and fall, causing turbulence, and finally, visibility and cloud clearance.
Wind shear. The question you might see, at what elevation can you experience wind shear? And the answer is all. Another term that I saw in one of my tests, I was surprised, it's called lapse rate. And it's the rate at which the temperature in Earth's atmosphere falls with altitude. As we know, the higher you go, the colder it gets. An adiabatic lapse rate, adiabatic means unchanging lapse rate, involves temperature change causing the rising or sinking of an air parcel. This typically forms a stratification where it might be cold, warm, or cold, and it doesn't break up. And it holds sound, smog, everything underneath it. When flying a drone, you need to know about what's going on with the wind. I highly recommend you go to your manual and you look at the wind tolerance specification for your drone. So let's say it's 35 mile an hour. I will not fly in anything over 30 mile an hour, and only then if I have to, because if the wind speed exceeds the drone's wind tolerance, then the wind's telling it where to go, not you. So wind and currents can affect a drone performance and maneuverability, all phases of flight. Be vigilant when you're operating a drone near buildings, man-made structures, natural obstructions such as mountains, bluffs, or canyons. Because of wind resistance, you can get some unexpected wind gusts and direction. What happens when you hit a tall building? Well, halfway up, if you get close to it, it's forming a downdraft. Above halfway up, it is creating an updraft. If it is blowing fast, that situation is worse. So the speed of the updraft or downdraft is a function of wind speed. Now, when wind blows over a subject, you have a updraft on the wind side, you have circular turbulence on the other side. Now, there's something called the Venturi effect, which is if you have two buildings not far apart, then the wind speed in between those buildings is accelerated. Now, this also happens on thin upslopes that can compress the wind speed and make faster wind gusts. So obstructions on the ground affect the flow of wind, may create rapidly changing wind gusts. The intensity of the turbulence associated with ground depends on the size of the obstacle and the wind. Now here's an effect that I might see. I live in rural North Carolina, and often we'll have a farmer's field, a grove of trees, and another farmer's field. Well, if you're on the windward side, there may be a mild updraft, but there's turbulence right next to those trees. And when you're on the leeward side, you might get a downdraft, you might get an updraft. You definitely can get unexpected wind results, and you have to manage it. If possible, give yourself room and don't tend to fly close to obstacles. So high winds make it difficult to maintain a geographic position in flight and may consume more battery power.
The friction of the wind blowing along the surface of the Earth actually changes its direction from, say, about 2,000 feet above ground level. Local conditions, buildings, and other man-made structures, geological features, and other anomalies can change the wind direction and speed close to the Earth's surface as well. And that's where I want to focus. So first, let's talk about convective currents. Different surfaces radiate heat in varying amounts. Plowed ground, rocks and sand, barren land, all of these things give off a large amount of heat, whereas water, trees, other areas of vegetation actually tend to absorb and retain the heat. So this uneven heating of the air creates small areas of local circulation called convective currents. Convective currents cause that bumpy, turbulent air sometimes experienced when flying at lower altitudes during warmer weather. On a low altitude flight over different types of surfaces, updrafts are likely to occur over areas like pavement or sand, and downdrafts often occur over water or expansive areas of vegetation like a group of trees. So hopefully this illustration shows you that different types of land will affect the normal flight path of, in this case, a fixed-wing aircraft. This is particularly true, this concept, when it comes to shores of large bodies of water. The land will heat up faster than the water, so the air over the land becomes warmer and less dense. It rises and is replaced by cooler, denser air flowing in from over the water. Have you ever heard of a sea breeze? The weather phenomenon. That's what's happening here. These are convective currents at work. And at night, the opposite happens. The land cools faster than the water, so the warmer air over the water rises and is replaced by the cooler, denser air from the land. This creates an offshore wind called a land breeze. Anywhere there is uneven heating of the Earth's surface, you will find convective currents. Another atmospheric hazard here exists that can create problems for remote unmanned aircraft pilots. Obstructions on the ground can affect the flow of wind, and this can be an unseen danger. Ground topography and large buildings can break up the flow of the wind and create wind gusts that change rapidly in direction and speed. These obstructions range from man-made structures like the ones you're seeing in this illustration, hangars, to large natural obstructions such as mountains, bluffs, or canyons. And of course, the intensity of that turbulence associated with the ground obstructions depends on the size of the obstacle and the primary velocity of the wind. But just know that you need to be especially vigilant when flying around large buildings or large natural obstructions. This is one of the many reasons it's important to scout out your flight environment and to map your shots ahead of time, deliberately considering large obstructions and how that might affect your flight operations. Let's go through an example. Let's say you are flying your unmanned aircraft in the mountains. In a mountainous environment, you've got wind that flows smoothly up the windward side of the mountain, but on the leeward side, the wind follows the contour of the terrain and can actually be quite turbulent. This is called a katabatic wind. The stronger the wind, the greater the downward pressure. The wind will actually push your unmanned aircraft down toward the mountain. If you don't know how to recognize a downdraft, which is downward moving air, then things can get quite severe. Again, it's really important to be aware of how natural and man-made obstructions affect wind flow.
When you see temperature and dew point close, then something to happen. Okay, there are a number of fog questions on the exam. Radiation fog. The land gets heated up during the day. The sun beats down, makes it warm. As it does, the heat picks up moisture and goes up. So heat radiating from the surface at night cools the bottom air until it reaches saturation and you get fog. This fog only lasts if there's little to no wind. And if you've been out in the morning and you've seen this radiation fog, it tends to lay close to the ground. And as soon as the sun has a chance to heat up the ground a little bit, it burns off. Warm, moist air moves or advects over a cold surface, picking up moisture. As the air cools, you may go over land or something that is cooler. It reaches the saturation point and fog develops. So you do need a bit of wind to carry the wet, moist air, typically over a body of water, to saturate the air. And then as it flows over the cooler surface, it forms advection fog. Upslope fog is just what it sounds like. Remember, it cools off as you rise in altitude, so your moist air blows up the side of some obstruction and it cools off until the moisture condenses and you get fog, precipitation fog. Rain falls through the air. It hits a surface. Now the surface is warm enough to evaporate some of that rain. And as it goes back up, it hits the dew point and comes out as fog. So you may see this fog over parking lots.
Radiation fog typically forms in low-lying areas, like a mountain valley. And it's going to happen when the ground cools rapidly due to terrestrial radiation and the surrounding air temperature reaches its dew point. Radiation fog happens on clear nights with relatively little to no wind present. Then as the sun rises in the morning and the temperature increases, radiation fog lifts and eventually burns off. Also, an increase in wind speed can speed up the dissipation of radiation fog. But just remember that it happens typically in low-lying areas like a mountain valley, and it tends to form on clear nights with relatively little or no wind present. Advection fog is common in coastal areas where sea breezes can blow moist air over cooler land masses. Think about the beautiful and foggy beaches of Northern California, Oregon, Washington, the Pacific Northwest. It is absolutely beautiful up there. Very foggy. That's advection fog. Advection fog is likely to form when a layer of warm, moist air moves over a cold surface. Unlike radiation fog, wind is required for advection fog to occur. So winds of up to 15 knots allow the fog to form and intensify, and then above a speed of 15 knots, the fog usually lifts and forms low stratus clouds. This type of fog can persist for days. Upslope fog occurs up a slope. There's moist, stable air. It's forced up sloping land features like a mountain range. And similar to advection fog, upslope fog requires wind for formation and continued existence. But unlike radiation fog, which can burn off with the sun, upslope fog can persist for days. Steam fog is common over bodies of water during the coldest times of the year. And because of that, it's also known as sea smoke. Steam fog forms when cold, dry air moves over warm water, and as the water evaporates, it rises and resembles smoke. Low-level turbulence can occur, and of course, icing can become very hazardous with the presence of steam fog. And speaking of ice, finally, there is ice fog, which occurs in cold weather when the temperature is way below freezing.
Stratus clouds, those are those thin, wispy, very, very high, and that is stable air. Cumulus clouds, those are the puffy. They have a lot of vertical development, and they are unstable air. When you see nimbostratus, cumulonimbus, nim being rain, you can project that it's highly likely that the air is unstable. The question usually contains the term over a mountain almond shape cloud. That is a standing lenticular cloud. Dew is on cool, clear nights. The temperature of the ground and objects on the surface causes the temperature of the surrounding air to drop below the dew point. When this occurs, the moisture in the air condenses and builds itself on the ground, building objects like car and aircraft. They want to trick you on this. This is above freezing. So if the temperature is below freezing and the same phenomena occurs, then it will deposit ice or frost. And that can be a serious hazard. Commercial airplanes gets on the wings and disrupts the list. I don't know that I would leave my drone out where it could get a load of frost, but if you do, you need to thoroughly clean and free of frost prior to the beginning of flight. And what you need to make sure are frost free are the props. So what is temperature and dew point? We've heard the term. Dew point in degrees is the temperature at which the air can carry no more moisture. Ceiling, lowest broken or overcast layer. If you see scattered, they do not qualify as flying. They don't matter. So if you see scattered and few or clear, you don't have to pay attention to the ceiling. And clouds are always reported by weather stations in AGL. The next thing that we're just going to deal with is the fact that the true north of the Earth is not in the exact same place as magnetic north. So if you're using a compass, you will be looking at magnetic north, and it will be in a different location than true north. And matter of fact, magnetic north drifts around. If you read it, it's true north. If you hear it, it's magnetic north. And if it's a brief, they're going to give you a true north figure. So the next thing we're going to talk about is flight service and NOTAM. Once again, you want a weather briefing, 1-800-WXbrief.com. Question might be, when will clouds or fog form? When the water vapor condenses, when the temperature equals the dew point. Another type of question, what kind of air would you expect over a barren area on a hot day? Unstable air, thunderstorms, hot, humid air, moisture, temperature inversion, instability sending it aloft.